All right, everyone, lesson 10.2, probability of compound events. This should be familiar to you, but we will refresh your memory in case you forget. Compound events are two or more events happening simultaneously. In this class, for all the examples we do, it's usually going to be two events happening simultaneously. It could be 3, 4, 5, 6, or whatever, but we'll always usually focus on just two things happening. So, like, you have two types of compound events. You have what are called mutually exclusive, and then you have what are called overlapping. Mutually exclusive means they have nothing at all in common. Like rolling the number 3 and rolling an even. They have nothing in common. 3s are not even, and evens can't be the number 3. So they're totally separate of one another. However, overlapping events could, hence like the name says it, overlap. Like rolling an odd and rolling a prime, because some odds are prime and some primes are odd. So overlapping, we have to make a special consideration for whenever we have overlapping events. Like, see these numbers in here in the middle of the Venn diagram, the 3 and the 5, because they're both odd and they're both prime. So it's important that you don't double count. When you're adding up probabilities, you don't double count those events that fit into the odd and into the prime groupings, okay? We'll discuss that more in an example in a minute. So here are the two rules, and these should be memorized, these two rules. If you ever see the word or, you are adding the probabilities. Or means add. If you ever see the word and, you are multiplying the probabilities. All right, those are the two rules that you need to remember. If you see the word or, you add the probabilities. If you see the word and, you multiply the probabilities. So like, example 1, find the probability that you roll a 2 or roll an odd. Okay? So rolling a 2, well, that only happens 1 out of 6 times, right? Because there's only 1 2 on a die. Or, so you're going to add, right? Rolling an odd. Rolling an odd is going to be 3 out of 6, right? Now, we have to think, before we add these together and get our final answer, we have to think, do these overlap or not? Is the number 2 an odd? Or are odds the number 2? If the answer is no, then you just add your probabilities and you are done. 4 6, which is 2/3. However, if they overlap, which we will see in, I believe, the next example. No, that one doesn't overlap. Like down here, ready? Let's do this one down here, number 2. You could do the ones we skipped. You roll a number cube. Find the probability that you roll a number less than 4 or an odd. Okay? So the numbers less than 4 are the numbers 1, 2, and 3, right? So that's 3 numbers out of 6. So the probability of getting a number less than 4 is 3 out of 6. Or, which means we're going to add, an odd. Well, there's 3 odds, right? So that probability is also 3 out of 6. So we add them together, we get 6 out of 6, right? And the answer is 1. Problem is that's wrong. That is not correct. Because these events overlap. There are some numbers that are both less than 4 and odd. Namely, the numbers 1 and 3, right? So the numbers 1, 2, and 3 are all less than 4. The numbers 1, 3, and 5 are all odd. See how the 1s and the 3s overlap? They're in both groups. But we counted them twice. We counted the 1 and 3 in the less than 4 group, and we counted the 1 and 3 in the odd group as well. You cannot do that. That's called double counting. So we don't double count. We don't double count. So what I usually just do is I just cross them out, usually. If I know if I'm counting the 1 and the 3 in the first group, I can't count them in the second group. So now it doesn't matter which one group you cross them out from, as long as you cross them out once. So now our real answer, this is no longer 3 out of 6. This is really 1 out of 6 now. Because now we only have one number that satisfies the odds. So we have 3 out of 6 plus 1 out of 6, which is 4 out of 6, which is 2/3. That's the correct answer. Okay, so if you didn't think to eliminate the double counted numbers, you would have had the wrong answer.